This okay. This is the ECE 173 final project. Okay. Um, this is the first function. This function. What it does is it generates an array. It generates a dynamic array. So I initialize the function as a function pointer, and it takes in a size. Okay, and the first bit of the function is this. Rmax and rmin. I just initialized it, and then I seeded the time to null. This part I initialized the pointer as well. What I did here is I used the malloc function to dynamically allocate memory. So, and then I stored the result in PTR. So what this does is it takes a 4-byte size memory, and what it does is malloc PTR stores the first address of the allocated memory block. So I'd store the address 0, and then you can use a for loop like right here to get the rest of the dynamically allocated array. And then I used the random function so that the array populates with numbers from 1 to 20, and not any bigger or less or lower. And then the function returns pointer, returns PTR as a pointer. And then in this function, displays the array, so it takes in an already generated array. So, and then it takes in a generated array and then array size, and then just populates the array. Just populates the array. And then this function, what it does is it frees up the dynamic array. So it takes in an array, which is a dynamic array, and then it uses the free function to free the memory space. And in the access one, it takes in array, and then a number the user wants to access, and then array size. So if the number in this if statement, if the number is negative or is bigger than array size, you get an error. If it's a valid number, then this printf displays it. Okay. For the modify function, it takes in the same stuff, but it also same stuff as access. But in this case, it takes in a modify, like an index, the index the user wants to modify, and then what they want to modify with. This if statement, it does the same thing. If it's negative, the number is negative or greater than array, you get an error. If it's a valid number, then this line of code modifies it. So it makes whatever value that index, whatever value they want to modify, you change it to what they want to modify it to, and then you display it. You display it right there with the printf. This delete function, it takes in array, and then the one different thing is it takes in, instead of just taking an array size, it takes in a pointer of the array size, because it doesn't work if you change the array size in the function. You want to change the array size. You want to change the address of the array size, and then later in the main you can actually change the array size that way. So you take in a pointer instead of the actual array size, and then you also take in a number the user wants to delete. So this if statement, this for loop right here, what it does is it goes through the array and it checks if the chosen number is valid. So if the chosen number is in the array, then this if statement is done. So this whole entire if statement, I made count 0, and then I initialized this array with the array size, or it's a different array. So this one, I made this array to store any duplicates, any duplicate numbers that I want to delete. This for loop, what it does is it checks where all the numbers are equal to the chosen number. So if there's 3 duplicates in the array, then then count will count 3 times. So count will equal 3, and all those duplicates, the location of the duplicates will be stored in here. So, and then I initialized it with the count. So the first index will be whatever count is, and I made it equal to I, so it works with the for loop. All right, and then this part took me a while, but it's a nested for loop. So what it does is I is equal to the count minus 1. So because you're initializing, you want to take the first time. I tried different ways, but if you just have count without the minus 1, it doesn't work. You're gonna be left with one extra duplicate all the time. So I subtracted 1 from count, and then that worked. And then I decremented it because I want this nested for loop to go in reverse or go downward because it's gonna start from count. And then I initialize position. So position, what it does is it keeps changing. The value of it keeps changing as the for loop goes on. But in the first part, you make position equal to the first number or the first location of the index value or of this array basically. And this array stores all the values of the duplicates. So position is going to equal the first value of the first position of the duplicate. And then when you have the first position of the duplicate, you can do this for loop. This for loop basically is a simple one, it's just a simple one. All it does is just basically it shifts all the numbers to the right, and then it keeps doing that. So after the first position is deleted, and then does it again. So position gets a new number, it deletes it, and gets a new number, it deletes it, all the way till there's no counts left, or till however many duplicates there is. And then in this line of code, it just resizes the array. So, and this part is why you need to have array as a pointer, because if you don't have it as a pointer, it won't work. Whatever happens here won't happen in main, basically. And then, okay, let's move to the next function. This one is insert array. It takes in the same stuff. It takes in a chosen index and a new number you want to insert. Same thing, if it's negative or greater than array size, you get an error. If it's valid, the same thing happens. There's a shifting. It's not resizing, it's like shifting. So you shift the arrays to the right, and then when you shift everything to the right, you will put there'll be like a little gap, and that gap is where you put the new number. So the new number that the person wants to insert. And then you do it right here. This is the line that does it. This only works if you do the resizing ahead of time. So yeah, my friend's gonna explain that on array. Yeah, and then that's all of them.
Okay.
Yeah. Alright, here we go.
Okay. So this is the main function. And all the things that he went over is going to be sort of the function, like the outside functions that will be controlling what we do with these if statements, or not if statements, but case statements. Into main, we can start out with the array size, number access, index, new number, and these are just all of the initial numbers that we're going to be using, and yeah, that's all that is. And right here it says how many elements do you want in the array. The original size should display the original size, and then it says generate dynamic array size and display the original array. And then right here it says while, because this is going to be the main loop here, where it's going to go through whatever we type in. It's going to give us whatever we want. Whatever we type in is going to give us, is going to go through each one of these cases, and then it's going to provide us with what we want out of what we typed. For example, the dynamic array menu shows up, and then it says select an option, and then these are going to be the options here. And enter a choice from 1 through 6, where you can only allow these 6 options here. And then it says, and then it's going to switch between each case depending on what you type in. For example, if you typed in if you want to insert an element and you type 1, it's going to ask you what number do you want to insert, then it's going to ask you in which index do you want to insert the new number, and then it's going to ask and then it's going to use the functions from on top with a real lock and the memory allocation, because we allocated some of the memory from on top here, and it's going to show the original array, and then it's going to adjust the original array size. That's what real lock allows you to do. It allows you to store the memory and then also like edit like the size kind of, and this is what this is meant to do right here of that array. It's going to add another number to the index or add a new number, like resize the array to accommodate that new element. And this is the dynamic array insert. It's also just calling to the former function that we have on top, that is the dynamic array underscore insert. Array size equal array size plus 1, and that's going to be how the updated array size is going to be. And this is case 2, which we're going, when you type in the number that's let's see, what is it, which 2, yeah, if you type in 2 in case 2, and I mean if you type in 2, case 2 is going to allow you to enter the number you want to delete, and the functions on top shows you how the functions on top that he went over goes through how to delete it. And this is delete dynamic array, original size, and array size, and delete number. And yeah, and for this one is access, and we are going to enter the index value of the element you want to access. You just type in whatever index you want to access, whether it's 1, 0, 5, and it depends on how much of numbers are in that specific array for you to choose the index. We use break, by the way, in order to make sure these don't continue running on their own, and that's what the break is supposed to do. And case 4 is modifying an element. We enter an index of the element you want to modify, call it index modify, for example. Printf, with what number do you want to replace that index value with, and call a new number. And modify dynamic array, original array, index modify, array size, new number modify. And what this is doing is kind of similar to these, where it's just sort of calling that function that's all the way on top down here. And case 5 is display dynamic array, and what this does is just puts this here, which is like going to call what's on top, and it puts these two things there. That's what it's going to be messing with. And then break, of course. And case 6 is when you just click exiting, and it's gonna print exiting, but ours is just gonna exit as well. And an invalid option, please select from this if you was to choose a number like 7 that's above our limit for what we need in order to go through these cases. No. And this is just free dynamic memory array, free the dynamic memory, free dynamic array, original array, and return. So now we're going to run it and see how it will work. How many elements do you want in the array? We're going to say we want 10 elements.
Hopefully you get duplicates. I do get duplicates.
Okay, so we got 29, 9. Okay, now let's say we want to insert an element. Now enter the new number you want to insert, and the new number I want to insert, let's say it's 1, 2, 3, 4, so it could stand out. And the index I want to type it in is, let's see, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, let's say I want it in index 10. Let's say that. Now let's display that. Bam, see that? All right, now we're going to delete. Let's delete what I just put in. Now let's display it. Alright, I deleted it. Now let's access an element. We're going to use.
Oh, try if deleting duplicates works. So I'll go to delete and then delete one because there's a bunch of ones in there. And display, it should delete all the ones in the array. Right now there's like 3 ones. There should be 0 ones.
Delete it.
All the ones, nice. So
okay, so it worked. And then now we're going to modify element, or modify element. Let's modify the 9s. Modify 4, and then enter the index of the element you like to modify, and that index will be 0, 1, 2, 3, 4, 5. With what number? Let's say with 1, 2, 3, 4. For 5 is 1, 2, 3, 4. The value at index 5 is 1, 2, 3, 4. Alright, now let's display and see what it displays now. It displays 1, 2, 3, 4 as the value of 5. And now we're going to use the exit function. And it's exiting.
I'll do the. You can just show the sources that we used.
Okay, awesome. Time to go to our sources.
All right. Yep. And then just right there, program. Use program. This was a good one.
Program Wiz was amazing in finding how our memory allocation works because.
Zoom out real quick.
It's,
go ahead. Yep.
It's recorded.
Yeah, it's recorded.
Okay. Program Wiz was instrumental in us finding out how to really use memory allocation. It shows us right here how to use malloc, how to use calloc, how to use free, and what they mean, and then it showed us examples of how you can use them in your code. Calloc as well. Output. It even explained how realloc works, and actually showed us an example of how realloc would work. And it was very important in us finding out how to use.
That one, this was the one I used. It showed me different examples. This one was really good because it showed like different ways you can delete. It was a good example on how to like delete arrays, like delete duplicates and array values, whatever. Yeah, it showed like 6 different examples. So the one downside though is it didn't show how to delete duplicates. It only showed how to delete like specific numbers with specific positions. So I had to figure out myself how to like delete duplicates, which took a lot of trial and error. And then this, let me go to this one. This was like a good video I watched. It was like it showed how pointers work. It was like a 18-minute long video, but it helped me a lot. So I like learned how pointers work. Video, whatever. Doesn't matter. It was a good video though. These are the main things that we use to get the project done.
Awesome.
All right.